In this video, we will learn how to find the probability of events involving the word and probabilities with independent events. Independent events are two events that do not affect each other. For example, if event A is flipping a coin and getting heads, and event B is flipping the same coin a second time and getting tails, then the two events are independent because the outcome of the first toss has no bearing or effect on the outcome of the second toss. The formula is, if A and B are independent events, then the probability of A and B equals probability of A times probability of B. If you recall, when we use the word or, the probability of A or B is equal to probability of A plus probability of B. So in this respect, when you want both to happen, then we have to multiply the two events. In example 1, suppose you roll a single die twice. Find the probability of rolling a 5 first and then a 4. The probability of rolling a 5 and 4 is equal to the probability of rolling a 5 times probability of rolling a 4, using the formula that we just discussed above. The probability of rolling any number is 1 over 6. So 1 over 6 times 1 over 6 is equal to 1 over 36. On your calculators, you will more than likely use your parentheses around each fraction. And then you're going to simplify using math, enter, enter, and you get 1 over 36. Example 2, suppose a card is drawn at random from a standard deck of 52 playing cards. The card is replaced. The deck is shuffled and you draw again. What is the probability of drawing a 9 first and then a diamond the second time? Now we're drawing 2 cards, but you're replacing the first one, which allows us to use these two events as independent events. So drawing one card has no bearing on the other card. The probability of drawing a 9 is 4 over 52. The probability of drawing a diamond is 13 over 52. And the probability of drawing a 9 and a diamond is 4 over 52 times 13 over 52. And this is equal to 1 over 52 as a reduced fraction. Example 3, what is the probability of flipping a coin and getting a heads 3 times in a row? The probability of getting a heads is 1 over 2. Since we're doing this 3 times in a row, we multiply 1 over 2 times 1 over 2 times 1 over 2, and we get 1 over 8. Example 4, if the probability that South Florida will be hit by a hurricane in any single year is 5 over 19, what is the probability that South Florida will be hit by a hurricane in 3 consecutive years? That is, a hurricane hits South Florida 3 times in a row. The probability is 5 over 19 times 5 over 19 times 5 over 19. A shortcut on your calculator would be taking the 5 over 19 as a fraction, put it in parentheses, and then raise it to the 3rd power. And that's equal to 0.018. And if you want to express that as fraction, hit math, enter, enter, and you get 125 divided by 6859. Example 5, what is the probability that South Florida will not be hit by a hurricane in the next 4 years? Now, if you recall, the probability of an event not happening is 1 minus the probability of the event happening. So 1 minus 5 over 19 is 14 over 19. And we can do this on our calculator as well. Simplified fraction, 14 over 19. So that is the probability of an event of Florida not being hit by a hurricane. So the probability that they will not be hit by a hurricane in 4 years is 14 over 19 to the 4th power. I'm going to put this in parentheses and do it over here. And we get 0.295, rounded decimal to 3 places. In example 5, what's the probability that South Florida will be hit by at least one hurricane in the next 4 years? So this is the opposite of no hurricane in the next 4 years. Since we already know what the probability of no hurricane in the next 4 years is 0.295, so we subtract that from 1, and the probability of that happening is 0.705. Okay, so we took the complement of the event in example 4. So the probability of an event happening at least once is equal to 1 minus the probability that the event does not happen at all. Example 6, Elizabeth brought a box of donuts to share. There are 24 in total. 3 are jelly filled, 9 are lemon filled, and 12 are custard filled. You randomly pick one and eat it. Then you randomly pick another. What is the probability of selecting 2 custard filled donuts? The probability of getting the first donut as custard filled is, if you look up here in our options, you have 12 donuts that are custard filled out of a total of 24. So the first donut is 12 over 24. The next donut you pick, since we're also picking another custard filled donut, you've already picked one from a group of 12, so you are left with 11 custard filled donuts, and then you have one less donut from the total. So now you have 11 over 23. Multiply and we get 12 over 24 times 11 over 23, and that is equal to 11 over 46. Again, put these in parentheses and then use your math enter to write this as a reduced fraction. Example 7, what is the probability of selecting a jelly filled and then a lemon filled? And notice we have the word and. So we're going to multiply the probability of getting a jelly filled, and that is 3 over 24. And then the probability of getting a lemon filled, looking back up here in our problem, is 9 over, now we have 23 left because we already picked one of the donuts. So the total always goes down if we're not replacing them. So in cards, we can replace donuts. Good luck trying to replace a donut that somebody just ate, right? So we're going to multiply the 2 probabilities, and we'll do this together on our calculator. Parenthesis, 3 over 24, in parentheses, times 9 over 23. Math, enter, and we get 9 over 184. Example 8, consider a political discussion group consisting of 9 Democrats, 4 Republicans, and 6 independents. Suppose that 2 group members are randomly selected in succession to attend a political convention. Find the probability of selecting no Democrats. So first we need to know how many total people we have. 9 plus 4 plus 6 is equal to 19. The probability of selecting no Democrats is, now we have 2 people. So the probability of selecting the first person that is not a Democrat is actually 10 over 19, because we have 4 Republicans and 6 independents to choose from. So that's a total of 10 people out of 19. Then once we've chosen one of those people, we now have 18 left to choose from total. And the question is, how many would not be Democrats? Again, out of this 10, since we already chose one of those, we have 9 left. So 10 out of 19 times 9 out of 18 is equal to 5 over 19. Conditional probabilities. Find the probability of an event B given that event A has already occurred is called conditional probability. We use the notation P of B given A to indicate conditional probability. Okay, so what this means is this is the probability of B given that A has already happened. Example 9. Consider a well-shuffled deck of 52 playing cards. A card is drawn at random from the deck. Find the probability that the card is a picture card given that the card is a diamond. So from a deck of 52 cards, the given part tells us that out of those 52 cards, we have diamonds to choose from. Since there are 13 diamonds, the new total is 13. And the probability that that is a picture card, well, out of 13 diamonds, we do know that there are only 3 picture cards that are diamonds, the Jack, Queen, King. So the probability of getting a picture card given that we have diamonds is 3 over 13. The formula for conditional probability is the number of ways for both A and B to occur divided by the number of ways for A to occur. Okay. If you look at the example above, the numerator is the probability of A and B happening at the same time. That is, we're getting a picture card that is diamond, and there's 3 of those. And the denominator is the number of ways to get diamonds, which is 13. In example 10, suppose a 12-sided die is rolled. Find the probability that multiple of 3 is rolled given that the number is even. Now remember, the given part is always in the denominator. So in a 12-sided die, we have the numbers 2, 4, 6, 8, 10, and 12. These are my even numbers. There's 6 of those. So the given part, 6, goes in the denominator. The numerator is both a multiple of 3 and even. The numbers in B that are even, we have 2 of them that go right here in our numerator, and we have 2 over 6, which is equal to 1/3. Example 11, the table shows a breakdown of people's marital status in thousands in a particular city. Suppose a person from this city is selected at random. Find the probability that the person is divorced. So the number of total people that's in the denominator at the bottom there is 212.7 thousand. And then in the numerator are the number of people that are divorced. We go to this last column here, and the total number of divorced people are 22.3 in this city. So the probability is 22.3 divided by 212.7. And that's equal to 0.105. The probability that a person was never married or divorced, now we're using the word or, the disjunction, which is adding the 2 probabilities. So the probability that a person from the city was never married is 50.6 divided by 212.7. The probability that a person from this city was divorced is 22.3 over 212.7. Add the 2 fractions and we get a decimal equivalent to 0.343. Find the probability of a female who is widowed. So a female that is widowed is 11.3 over a total of 212.7. and that reduces to 0.053. Find the probability that a person is female or widowed. Now here we add the probability that a person is female is 108.4 over 212.7. And the probability that a person is widowed is 14.4 divided by 212.7. And then the overlap here is females that are widowed, since we don't want to count that twice. The females that are widowed is 11.3 over 212.7. Now we can add everything up in the numerator using our calculator. 108. This is the shortcut method to this. Instead of putting parentheses around each of our fractions, we already have a common denominator, so I only need to take care of the numerator and then put it all over 212.7. So we have 108.4 plus 14.4 minus 11.3. We have 111.5. Then we're going to divide it by 212.7. And the answer is 0.524. Find the probability in part E of a male given that the person is divorced. So the person is divorced is 22.3. So that is our new total that's at the bottom. And the number of males that are divorced is 9.6. So the probability that the person is a male given that they're divorced is 9.6 over 22.3. And that's equivalent to 0.430. Then our last problem, part F, find the probability that a person is married given that the person is a female. The number of females is 108.4, and the probability that that person is married given they are female is, so we look at the married females, and that is 61.9 divided by this 108.4. And that reduces to 0.571.